Welcome, I'm Bill Wake. We're here working on a programming language called Tenth, and we've done most of the compiler and interpreter for it, but one thing we haven't done is find a way to do input. So we're going to explore making a terminal go in raw mode so we can catch a character at a time. Now, I know we've not done very many things with the strings operations and all that. So we'll probably figure out some string operations we need too, but I think the basics, once this is done, I think we'll say the interpreter, compiler slash interpreter anyway, is basically ready for us to start doing applications. And along the way, we may realize, oh, we needed an extra routine or something, and we'll just add it, but we're closing in. Now, raw input's a little tricky. Basically, terminals have three modes that they use. One is cooked mode, where if you start typing and you hit the delete key, it deletes it, and nothing is really committed until you hit return. There's raw mode, which is what we're gonna try for. Basically, catches each character as it comes in, and the program has to decide how it handles a backspace or whatever. And then finally, there's one that's kind of halfway in between. I've seen it called half-baked, rare, half-cooked, C-break, because it's control breaks, but it's sort of mostly character at a time, but it still supports things like Control-C and Control-D that have meaning, Control-C quits a program and so on. We'll see what we can do with raw input. It's going to be tricky for us because I want to do it down at the Unix level, which is IOCTL, ioctl, I don't know how people say it, but it's the controller for a terminal. So it or other character-based input, but in our case, the terminal, and it controls how the input gets interpreted. I think what we'll do is develop this in C, and then take what we learn and try and do the same thing in assembly language. I really have avoided C in this project, and I still don't intend to include it in the interpreter itself, but I think it'll be the fastest way for us to figure out what's going on. And now maybe we can get a little ways into it and realize we know what we need from there, but I think we'll start there. Okay. Let's do a make. Well, all right, now everything should be green. Yeah, looking good. Okay. Good. Let's see. Oh, the other thing I did was I found another article on doing this that looks really good to me. So we'll probably basically try and replicate what this article does, and that should get us at least the C version. So basically, he's trying to. This is all part of a project to create an editor, maybe a Vim kind of editor. So he wants to read key presses. Well, the first thing to try is do a read and give it a one-character buffer and see what you get. And the answer is, because you're in cooked mode, I guess it's also called canonical mode, according to him, the character, that all gets it's just, it doesn't fit this one character at a time mode. So we want raw mode. All right, now, next one just checks Q to quit. All right, here's one. Turn off echo mode. So we mentioned tcgetattr and tcgetattr yesterday. That's like terminal controller get attribute or set attribute. And he makes a call. He creates a structure, makes a call passing in that structure. L flags are local flags. So he flips off the echo bit and then does set attr. So he basically takes that structure and plugs it in as the new version of the structure, and that should put things in raw mode. Well, is that, oh, he did no echo mode. Okay. So in this mode, when you type a character, it doesn't show up on the screen. So you may have seen this before. Some versions of sudo don't show anything when you type the password. Other ones write stars for it, but echo mode is what controls that. And I think he probably described that up here, but there are a bunch of attributes that get set together to make what we think of as raw mode. But this is the basic process we're going to do, you get you get the attributes for a term iOS, and then you change them, and then you set them, and that's kind of the core of it. Okay. Disable raw mode at exit. Okay, so this is another nice thing, because if you exited while you're in raw mode, you stay in raw mode, and that's awkward for working. The shell doesn't really expect that, and so on. So this is kind of a C trick, but he says at exit run the disable raw mode routine. Now our assembly language we're using, we don't get an at exit for free, so we'd have to do some work to make that happen. But we could work out something. I mean, it's not impossible, but in C you just say this, and it runs this routine at the very end. And he's doing the same stuff. It's just that he's added a new one to save the original structure. Okay. Right. Okay. Yeah. Here's canonical mode. That's the one I think of as being the core of it. So it's the same structure. It's just now local flag, turn off echo, turn off iCanon. Okay. So I guess, yeah, calling it canonical mode makes sense then. That's how it thinks of itself anyway. So, right. So when you've done this, now you're reading those byte by bytes. All right. So he writes a little program here. He enable raw mode, and then he gets each character and prints it. And what's this? If it's a control character, he prints a control, a character by character message. Okay. Yeah. Okay. Yeah. Arrow keys come in as 27, which is escape and a bracket, and then some more stuff. Backspace is 127. Delete is 4-byte escape sequence. Enter is 10. There's something about return that's a little funny, I think. Like maybe it gets mapped to 10 still or something. All right. Control A is 1 and so on. Yep, that's normal. If you hit Control S, yeah, you freeze your output. You got to do Control Q. That's normal Unix stuff or terminal driver stuff. Control Z puts you in the background. I don't know about Control Y. I've never seen that do that. You run FG to get back to foreground. Okay. By default, Control C sends SIGINT. So it's a signal, and Control Z sends SIG stop to suspend. Okay. Yeah, we can turn off both those. iSig, I guess, turns that off. All right. Control Y waits for the input to read input before suspending. Oh, okay. It's a Mac thing. All right. Disable Control C, Control Q. Okay. This is a different flag. I flag is an input flag, and X on is what Control S is known as X on. Control Q is X off. And here it's X on because it's an input flag. I don't know why they're not consistent. ISIG maybe should be LSIG. But at any rate, you can set that other flag and turn off Control S, Control Q. I'm not really too picky about that one. Control V, it sends literal characters. Oh, so if you hit Control V, Control C, you actually input a Control C. Again, I'm not too hung up on that. Okay, yeah, Control M. Control M reads as 10, which is Control J. So basically, return is translated to line feed, to new line. Yeah, so the terminal translates Control R into Control N, and that's another flag on the input side. That one might be worth it. Turn off output processing. Well, yeah, that one the normal terminal always prints a return and a new line when you go to a new line. If you turn this off, I guess you'll have to hit return yourself to do it. Okay, so I don't know if that's worth it. Miscellaneous flags. I don't even know what these do. Break interrupt. Some systems have interrupt keys that you hit and it pops you in the debugger or exits or whatever. Unpack. I don't know. Strip. Could be stripping like the 8th bit maybe or something. I don't know what CS8 is. Oh, he's going to say too. All right. It's not a flag. It's a bit mask. Okay. What does it do? Oh, character size. Okay. Okay. Strip. Yeah. Strip's the 8th bit. Old, the original ASCII is a 7-bit code. All right. Parity checking. Yeah. We're not going to worry about that. Break condition causes SIGINT. Yeah. Okay. We can add timeout. Oh, that's kind of interesting. Oh, okay. We saw this CC thing here. It's a set of control characters, and apparently vmin, I think, is that how long you're supposed to? No, one is how long you're supposed to wait. Oh, vmin is the number of input bytes you need. Vtime is how many tenths of seconds you're willing to wait. Okay. Maybe worth doing. Enable RAW mode. Okay. Yeah. Okay. Sections. Yeah. Well, okay. It's code cleanup kind of thing. Okay. So I don't know. Maybe this is maybe we should just pull this. I guess I don't want to spend all day on things. I don't know that we need all these flags to do what we want. But let's see. I lost my. Sorry. Read the attributes first, fill in the structure, change what you need. Yes, that's right. So I guess let's see if we click this. Do we get the program code itself? Oh, this is nice. Okay. And I'm not even going to work with Xcode, I think. I'm just going to run this at the terminal. Okay, so let's cat input here greater than well, he called it kilo. We'll stick with that. So I paste all this, turn and here, and bi kilo. Okay. So it looks like he's given us the whole shooting match here. Okay, and if it's a control character, he prints %D, the character. Otherwise, %C. Okay, so this case is the printable ones. Here he just prints the character number. Here he prints the number and the actual character. Okay, yeah, this seems like it's exactly what we're after. I mean, I don't think it matters. Like, we don't really need to do those. I don't even think we really need to do that or this. This is probably nice. Okay. Well, CC kilo. And man, I helped write a C compiler and I've forgotten everything about how to do the builds on this. It's some sort of load. Let's see. Where's our code? Did I bring that up? There it is. Okay, so in our make file, we can see what we do for assembly. It's probably similar. Well, maybe there's no reason not to edit that thing there in here, but all right, make file, get to the top. Load, macOS, L, sysroot. I don't know. If I do all that, probably have to say minus LC or minus libc. Do all that of kilo. Is there no O file? did I do backwards? Oh, A dot out. Oh, does that already build and run? Okay. Okay. Tab, 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 tab. 9s. Control C is 3. A is 1. J is 10. Return key is 13. Oh, okay. Enter key is 10, I think. Nope, 13. Let's hit delete. 127. Forward space, that's a sequence. Arrow key. All right. Oh, I've turned off the Control S stuff. Okay. Escape bracket capital B, escape bracket D, escape bracket C, and A. So that was my 4 arrow keys. Home. Whoops. I think that probably just, yeah. All right. Page up, page down. Oh, they did their thing still. Forward delete. Weird home button, world button. No, I get that. Okay. Anything else that's, oh, here's function keys. Whoops. Apparently some of those are still active. OQ, OPOR for function 1 through 4. Escape 27. Okay. And anything else? Control, Command, Shift. Let's do Control C. Command C, rather. Option C. Option Control V. Okay, the controls work the way you would expect. 30. I don't know what 30 is. No. All right. Yeah, Q to quit. Okay. Well, I was afraid we'd have to develop all that ourselves, so I guess I'm pretty happy to have that. All right. Let's put it in here. I guess we'll make a folder that's well, let's call it C demo. Okay, and we'll add that file in. All right, and then let's commit that, add keylot.c as a demo of raw mode. Okay. Now, really? Okay. Well, I guess we're going to take a look at a.out. So obj dump minus d a.out. Now, well, that's not so big. Okay. So somewhere we should see a service call, I think. Or no, we're going to see calls to getattr and setattr. Well, that's plus something. All right, let's look at the code while we're doing it. Okay, so disable raw mode calls tcgetattr. So disable raw mode. That's the only branch I see. Branch link. Wow, this code generates a lot of code. Standard in file number, tcsa flush. Move W0 gets 0, move W1 gets 2. load disable raw mode plus 24 OX24. Well, I'm not fast at adding these things in hexadecimal. Are we saying plus 0 plus 8? No, plus 4. Plus 4. 0 plus 4, 8, 12, 16, 20, 24. And that's x2. Well, that doesn't quite... I mean, standard in file number, that I would think would be the first one, W0. Because remember, the calling standard is first register, second, first register for first param, second for second param. W means these are shorts, and X's are full length. Okay, so this is an address. Well, somehow that should be the address of Origin term iOS. Okay, well, that's declared up there. I guess we'd have to look at the memory, the data area too. All right, but anyway, this must be the standard in is 0. tcsa flush looks like it must be a 2. And then Origin term iOS is somehow this plus 24. I don't get that. And then afterwards you add W8 gets W0 plus 1. Check it for not equal. TBNZ something branched on 0. Otherwise we branch to 3CD8. Well, that seems weird. Branch to the next instruction, right? And otherwise we die. Somewhere we compared it minus equals -1. You'd think we'd see a -1 in here. Maybe add S might be a subtract. I don't know. All right, but I think the key thing is this tcsa flush. Now, I think we could probably go in and break on, well, enable raw mode might be the better place to take a look. Wow, that generates a lot of code. I'm so used to our small little assembly things, and I feel bad if it's most of a screen. All right, let's find, well, there's branch to tcgetattr. Okay, so going backwards, there's the first parameter. And here's the second one. How is that plus 34? That's not even divisible by 4, so that just seems very weird. Add 1. Well, I think 8,000, OX1, whatever, 8,000 is probably the page of this section. Maybe it's the disassembly that's a little funny. I mean, this is 4,000. Now, I don't remember what X8 does. If it's just a temporary register. Let's see, do I have that open? No. Environment notes. I think it's just a temporary register. Oh, pointer to more arguments. Oh, okay. All right. Well, here's, I don't know, is that the call to tcgetattr? What's the point of adding 3F64 to it? Enable raw mode calls tcgetattr. You'd think we would see tcgetattr here. W0 is a 0. W1 is the address of the term IO thing we want to look at. If it's die, that, okay, then we get these flags. Okay, so those. I don't know what add-s does. W8 equals W0 add-s. Sort of too bad they picked a word for this. We're still in A. Okay, B. All right, now we're getting closer. Add and set flags. Oh, okay. So normally when you just do an add, it doesn't set the control flags for comparison. So doing an add-s saves you comparing. It builds in a comparison. Okay, so cset ne. All right, so that's like our if this equals 0, do this in one instruction kind of thing. tbnz, I don't know, but then we bl to die. Okay, so I think this one must be the equivalent of tcgetattr. All right, so we're gonna try debugging. And that'll be db a.out break set minus b, and I want to stop in enable raw mode. So let's break here. Ooh, can I say break at tc enable raw mode? And that could be this underscore. Okay. Let's see. Let's run. All right, and let's repeat that dump over here. Obj dump minus d. Well, let's do main obj dump again. Or maybe we have it already. Dumping. Minus d. Did we say more? No. Well, I definitely remember there's an attribute for showing the data area. Disassemble. Relocation. Well, I think we'll get by without it. Okay. obj dump minus d a.out. Okay, so now we're going to break at enable raw mode. Here's main, here's enable raw mode. Okay. So I really want to step down to here because this is tcgetattr. Okay, so we'll step. Okay, here's tcgetattr. All right, we'll step. Now, tcgetattr. Let's go look at that GNU version we saw the other day. Do we have it here still? No. Sorry, bouncing around here. Let's get this out of the way. Now, there's no guarantee that they're using the same code, but I feel like there's also it's sort of the natural code, so I don't think it's going to be too different. What I'm looking for is really that service call here. So I think it'll be pretty quick. We'll see something like that. tcgetattr. Okay. So, and I don't know, doing this kind of blind. All right, ARP-X16. Well, now that's branching right away. Whoops. Oh, okay. Well, no. I don't know what that's doing. It's branching to whatever X16 is, which was this stuff. I'm just going to step. We were at we would go to 3F70 otherwise. Let's see where we end up. Down here. Pack IBSP. Well, I kind of remember seeing that as an instruction, but I don't remember anything about what it does. I don't know if it's the equivalent of a service call. No. Add pack instruction to address. Oh, pointer authentication code. Yeah. So real apps. Okay, I don't understand why no call was exactly tc set or tc get. The addresses had an offset. I don't understand. I think it's probably something about the symbols that get exported or something, and maybe it's just all referencing off, like offset from the top of the file or something like that. But we could see it in the debugger mode, right? So we actually stopped at tcgetattr. So, it knows it's there. All right. So this pointer thing it's a thing. Basically, the compiled applications do this now. It's to make sure that somebody didn't just like throw a pointer at you for something and you would blindly use it. This validates it as being in some sort of correct range. And I don't remember the actual details of it. Using key B computes and inserts a pointer authentication code with a modifier in key B. Okay. Yeah. CR equals this. Well, they don't tell you what the difference is really. Back on BSP. Yeah, kind of hard to make out what that's doing, but what I understand is it's some sort of approach to putting some sort of key in so that when you use a pointer, that it can validate it somehow. Okay, so I think it's not in our way. I don't think. I'm not sure why it has to go through this. And actually, this whole bit here is kind of, where are we? I mean, it implies we're still in tcgetattr, but notice the difference in these numbers, right? 3F70 versus OX19, blah, blah, blah. I think this is some sort of system-y kind of thing. Hopefully we get back to like a return statement. Oh, symbol for ioctl. So we moved W1 7413. Okay, I'm going to just take a note of that. And then we move KW1 point, I don't know, 4048 left shifted 16. "16 bits is 2 words. So I don't know, are we constructing 4048 7413? And then we call ioctl? Now I don't know why this isn't a service call. It's a 19 BC8 B20. Okay, let's step. Okay, now we're going to jump to 19 BC 8B20. Oh, XF90. Well, I honestly thought it'd be a lot easier to figure out what was going on from this. X17, X16. I don't know what that would be. His set UGID is more like a system call. So we're somehow back in here. Load X18, contents of 17. Well, somehow this is going to branch us back to the contents of X16, I guess. Octal, okay. Step. Maybe this is the pointer check or something. Oh, there's another one. Or 8. This seems suspicious. Return AB. Okay, we're back in ioctal. Branch.low. There's a service call. Yay, finally. Okay. Service 80. But that's not what we're in, right? So I didn't see any service calls in what was supposedly IO control. So return should send us back out somewhere, not into the service call. Okay, we're back in IO control. Adjusting the stack. And I'm going to have to look at RAID tab. I don't know what that is either. Well, it's return AB probably, but. Oh, this is the validated. So this must be tied into that pack sub thing, pack IBSP, whatever it was. No, I think just the layout of set GUID probably it just probably happened to be after IO control. It's almost alphabetical. So that makes me feel like I'm theorizing correctly without knowing. Okay, well, what was weird to me is we did not make a service call. Maybe we're going to. I don't know, but retab makes me think we're not. Okay, so we're back in tcgetattr. Woof. Okay, and now we're back in enable raw mode. All right, so I mean, to me that means we're here. Or I think we just got to line 22, really. Add S, W8 is W0 plus 1. Maybe that's the check for -1. Somehow it should call add exit. Disable raw mode. Oh, there's symbol stub for add exit. Okay. So I don't know that we would execute that. I guess we do. Oh, exit. Okay. Shoot. I don't remember how to return. There's a way to step out of the debugger to your next return statement. Run, register. Oh, F. Hopefully this gets us out of add exit. Okay. Well, I don't know. Add exit. I'm going to say finish. don't know how to get out of here. Wow, pound DL-adder. I don't know, my finish doesn't seem to be getting me very far. BRAA, maybe get me out? No. AUTDA, don't know what that one is. But a BRA could get this out. Okay. Back to DL-adder. STP, I don't know. Start timer. Yeah, we're still. Can I break it as frequent instruction? Terminus raw equals orig. There's tcgetattr. Die. Well, I'm gonna break here. Somewhere we should see add exit. Oh, good point. Yeah. So X. Okay. Well, I'll step out for a while. This duration trace thing, I wonder if I'm screwing things up by being in a timer mode. Like if I'm in a timing loop. They seem different enough. I just want to get to that retab. Okay, there's start timer. Exit start timer, back in load address. BL to image map dad. I don't know. Maybe I'm. Yeah, let's try that. Oh, let's see, man. CC minus capital O none, I think maybe. No. O0. Okay. Well, I mean, he's got to call tcgetattr. I think that must be that. All right, well, db a dot out. Break set minus b. I think I want to break at this if I can. Okay. Run. Allow. Now, x0 is 2. x1 is some. All right, so that's the call here. I don't know what this, maybe it's X8. Okay. So we can see a 2. That doesn't seem to line up to what I expect. Do we have the IOCTL page up still? No. File descriptor. Now that should be 0, I think. Let's get this resolved. Zero is input. Okay. Yeah, so it's backwards from what I think it would be. Because I want the O in output to be match up to the 0 in input and the I to match up to the 1. Yeah, that's the opposite. Okay. 2 is error, though. That's consistent. Okay, so I would expect a 0 as the value. So I think whatever IOCTL call I'm at, well, it's probably this one. Or, yeah, I guess it's probably that one. Now, I don't think finish is doing any finishing. No, it's echoing. NI is step over. Okay. So, I don't know. I guess I'll keep going until I see a routine. Well, there's the IOCTL. Okay. Two. Big stuff. Yeah. All right. So I think 2 is maybe this. I don't know why the file number would be 2, though. That doesn't even seem relevant at this point. Okay, but what was it? It was NI? Oops. NI is step over. Let's try that. NI. Let me continue, and hopefully we get to the next one. Reg read x0 is 0. Okay, this is more promising. 0 is the input. Reg read x1. Well, I don't know what this is. Let's take a look at memory read C100. That. So that, well, that was when I wrote something down. I don't know what I did with it. Oh, fell on the floor. Okay. That was 74134048. Well, 4048 in front, 7013. Okay, whatever that thing was, that's that. All right, but I think based on this program, tcgetattr gets called before. Well, no, it does not. Enable raw mode gets called first. Well, whatever that 40487413 is, that That's there. And it did work the way we kind of thought, that it was shifting it in basically, because it shifted by 16. All right, so I don't see what that would mean. Well, we don't know this. We don't know the actual code, right? So that was this. We just know the code that GNU uses. tcgetattr. tcgets is 5401. Okay, let's go back and see if we see a 5401. Okay, that was X1, rated X2. Okay, I suspect that's just randomly still there. This thing takes 1, 2, 3, 4, 5 arguments. 0, 1, 2, 3, 4. Well, that could be that. Allocate buffer. I don't know. Seems suspicious. All right. The first argument is the IOCTL command or function service, maybe. I don't know. Then a 3, then a file descriptor, then tcgets. Okay, so let me see if I can find tcgets anywhere. Yes. Yeah, thanks. No. Yeah, it's the 4048 and the 7413 with 4048 on top. So that does seem to be what was happening with that left shift 16. So we skipped over the 7413 and ordered in the 4048. But we don't have a tcgets in our header files. Why is that possible? I really want to go see what this looks like, if I can get there. Okay, so I'm going to step. I guess I'll step until I get a BL. And then we'll step over that and return. All right, now where are we? We're in tcgetattr. X29, X30 is SP plus 10. So we tried LDP and didn't have any luck with it, interestingly. tcgets is IORT13 struct. Huh. Where are you seeing that? I don't think we're going to come up with anything. Ooh, that might be something. Oh. Okay. I feel like I should know what these are, but I think this is a type. This is going to be a type. IOTW. Not the right one. The macros describing the structure live in this IO type NR, IOR, size of size. So size is a misnomer. Third argument is this type. Okay. Yeah, great. But that compatibility file was open with text edit. Do we have anything that sounds like Git? Oh, Git line discipline. Well, where's this macro live? TTY chars. Oh, come on. Well, something, this struct term iOS, right? It's got to be getting the length of that structure. And I don't know how. Well, is that 47 whatever thing? If I do printf, term iOS size is D. And then okay, I think I'm going to quit here. Yeah, okay. $72, what the percent thing is. Well, T, I really should memorize my letters. I wonder if we can find that macro somewhere. But I mean, I think what I think it's going to be is going to be some sort of, you know, byte for the T and a byte for the 13, or maybe a couple bytes for the 13, and then something on the size. But 72, well, what is that base 16? Is 48? 4 times 16, 64 plus 8. So, I mean, 4048, right? That 48 is suggestive to me. Whether it's anything really. For T is Well, J is 10. Well, U, V, W, X, Y, Z, right? So T is 20. 20, which is hex 1, 4. And there's a 13. Well, and we had OX7413. That's a 13. 40, which is not in the alphabet range. Oh, no, is it? It is. 65 is A, so 40 is whatever comes right before A, if that's meaningful. 74, I don't know what that would be for. 7 times 16 is too big for my head. 8 times 16 is 128. I guess 112. It doesn't mean anything to me. 40. Let's see if I can find that ASCII chart again. Do we have hex? Yeah, 40 is at. Yeah, the character right before A. Ugh, I don't know. I don't see a T in there. 74. Yeah, OX40 is the at. So, I mean, if we translate 4048 7413, 40 is at, 48 is 72. Well, I think the 48 is 72, maybe. But the struct size was 72, so that makes me wonder if the 48 is the 72. So if it's at 72 and then 74 doesn't mean anything to me. Let's see what 13 hex is. Device control 3. Yeah, thanks. Sorry, that was 13. Well, 13's return, right? M. Control M. And then 74 in ASCII, hex to ASCII. I don't even know. That's big. Lowercase t. Oh, well, that's promising. Because you had a lowercase. Oh, the file on my system had a lowercase t there. So it was T74. Okay, so let me put this somewhere we can read it together. Okay, so the value we saw was 4048 7413 was hex. And then if we said 40 equals at 48, OX48 equals 72, '74 is T, and 13 equals control M. Okay, well, I find that somewhat suggestive, right? Because the macro, where did that go? It's either here or it's on my, okay. So it was T13. Okay, this one. I don't see 13. But yeah, I think that's the T, and the 13 is, well, no, that would be, I don't know. That's 13 hex, right? So it's 19. I don't think we got 19 here either. Hmm. But yours said T13, and this one doesn't happen to mention it. But the 13 was hex. I mean, we're just so close on this. Um, where's those flags? They're not in here. But the at 72, I don't know what the at has to do with anything, but 72 is that structure size. So I could see the IOR macro being, you know, put at and then the structure size and then the letter T and then the number that comes after it. Except I don't know how to relate the 13 to anything. I don't know. But I mean, I think these things, what it looks like to me is this, like these are like subcodes or something, under the category of this main code. T127 is BIS local mode, bit set. T126 is bit clear, so I think of these as being instruction-y kind of things. W versus R, I don't know, read versus write, and maybe that does turn into a bit thing somewhere. Um, but yeah, why we don't see a 19, and that I don't know, is just if this thing is just not filling out enough for us. But I mean, TIO get C, that sounds, oh, get special characters. That's not what we're doing. But like this line discipline thing, that's sort of the canonical line editing stuff, I think. Hang up on glass close, yeah. Oh, get TTY, STTY. I bet you those are that. TIOC get P. This is the structure. SG, speed, O speed, erase, kill. That's a little different. Oh, we're just right on there. 101, 011. Hmm. 111. But I mean, we saw something like this somewhere, but I don't know what level this is. I mean, IOCTL compatibility. And the worst is, we know whatever that 404874113 is, we know it's the right number because the little C program runs for us. So where it's getting its information, I mean, I can't even tell, right? These header files, well, maybe we can find them. I haven't done much C on my Mac to know, like, do they, where do they get them? Okay, well, this is down there a heck of a ways. Developer tools, same size-ish. Oh, macOS 13.3. This one was 14.4. Okay, so I think these are the right. Okay, so this is the most recent. Let's look at this one. Text edit. Make Termio look like TermIOS. tcgetattr. Okay, this is kind of related. Define tcgetattr as FD. Oh, okay. So in this one, at least, they don't need to do the translations like the tcgetattr code we pulled up from GNU. They apparently don't need it because they just map this right to the IO control command. Okay, so that tells us we can just do IO control. File descriptor command, I think, is this 4048 thing, and then arg is the address of the memory it's going to put in. Well, there's all those flags we looked at. I mean, this is almost exactly the set. So what's this file? NC. I don't know what NC is for. North Carolina, where I'm from, but I don't think that's it. Oh, and if it doesn't have that, then we use NC min-GW. So I don't think we're doing NC in min-GW here. All right, let's look at the other one. I don't know where it went. No. Is it here? Oh. Locked, that's a good sign. There's that Exxon flag. Well, there's the TermIOS structure. Okay, well, what I'm tempted to try, let's see, I missed 2 comments. Yeah, I think what I want to try is let's do this in assembly language. Let's set up a call to IOCTL, which we know to do with a service call, and file descriptor is 0 for input, and then we'll plug in that 4048 thing and pass the address of some memory with at least 72 bytes. And we make the call. That should be, well, that's the set adder, tcgetattr. I wish I knew where this was being defined. In curses. Oh, that's the NC. Ugh. New curses. Well, if we can find this file. I mean, like I mentioned yesterday, curses sets up a sort of a screen-based, text-based screen where you can place things in different lines and do that sort of stuff. Maybe use arrow keys and all that kind of thing. Now, this tcgeta, let's see if that's in here. No. Okay, let's find this file then. Okay. No, config.hen. What the heck is that? .h interface for Ada. Oh, he doesn't really like playing with others. Okay. Or was text editor the first one? I missed it. Yes. Okay. I'm guessing this is Ada's version. No? Okay. Generates config.h defs. Include incurs def.h. Now, this must just not be used. Oh, well, I don't think that's getting us there. Realizing I lost my gut. Usually in the IOCTLs. Do we have that one open? Term IOs. Right, we don't have an IOCTLs on this system. I keep coming back to this. All right. And I think that lowercase t is for terminal, by the way. You know that we're we're in the ballpark, but we're not quite home. All right, where did I lose this? Okay. And this is encouraging to me, but I don't know if that's what that argument is. Okay. Let's. Do I have this? Yeah. Let's see. TC get attribute. No. I want a Mac example of TC get A. Will that give us anything? Yeah, Linux. Mac terminal. Unix. Yeah, there we go again. Term IO instead of term IO. Yeah, so term IO is the Unix level, and I think term iOS is maybe the C level. TC get A is 1, but that's this macro. if the 13, which one's the T? The 40 is T. $13. Yeah, so I think we could try instead of 404874113, we could try that or try 01 and see if maybe, I mean, TC get A like it's the first thing, right? So I will get something. Okay. Now I don't know where to best put this in our code. Also, I'm going to take these things I headed out. Exit one. Okay. So right. Okay. Not really doing anything. Okay. Let's see. Well, I guess we got our playground, right? Let's try it there. So the playground, we just say global start. We can do anything we want in here. All right. So a service call. So let's move x0 gets 0. That's standard in. I think, well, let's try this. Move x1 gets OX40487413. I bet that doesn't build. I'm going to put standard epilogue return. Okay, and then in here, I think that's all they did. Oh, they did Unix exit. Okay. Come on. Oh. I'm not sure putting the key that makes Cersei or whatever it is kick on. Okay. Right. And then get attributes. X2 is L input buffer and service 0. I believe that's how you call a service command. So let's find our Unix functions. Yeah, Unix read X1, X16. X2 is the count. X16. Oh, we got to figure out what IOCTL is. Move X16. Oh, I know. I had a page of those at one point. All right, I'm gonna close. No, let's find our. Unix Mac service numbers. It's all just the wrong level. Oh you know what it is, that book. I don't know if I referenced that link somewhere. Well, it's probably environment, right? This thing. Nope. Developer action directives. Nope. Macros directives. Maybe it's in here, like way early on. Yeah. Yep. This. macOS linker doesn't like doing relocations. Okay, yeah, there we go. The Unix API calls function numbers. Okay, now where do I find those function numbers? He gave me code somewhere. There it is. Yes. Syscalls.h. Okay. Oh, goodness. Really, we don't have one. Syscall.h. Well, I've been here looking before, that much is clear. Right. Syscall.h. Is that a link? Should be handy. Oh, is this it? Yes. Okay. $54, and these are decimal. Looks like. Yep. Okay. 54. All right. So I guess I expect that to go into raw mode and then screw up my terminal. Take a break. That's a great idea. Let's take 3 or 4 minutes. We'll come back and see if we can make this thing do something. Okay, welcome back. All right, so we've got this thing. Let's see. We're passing in 0. We're passing in this constant we saw in the C code that we've sort of convinced ourselves has T and 13 and the count and something extra. And we've got a system call that the input buffer is the X2. So somewhere to put this, we're calling code 54, which is IOCTL, based on this H file somewhere here. Yeah, this is call.h. Make sure I got the right number. 54 cis-ioctal. Okay. Excuse me. All right. And I guess we just had to build this. So we got a make file still somewhere here. I don't know if we put Unix test playground in a make file. No. Okay. Let's do that. And what does he include? Similar macros, Unix macros, AS unit macros. Unix functions. Yes, unit. Well, it certainly needs AS unit.o. That might be all. Yeah, he doesn't like that. Okay. Oh, I got a little bit of junk added in there. I say okay a lot. In this one. I don't remember how our C code did it. It was like an add. X1 equals X2 LSL 16. It was something like that. Let's find that dump. Okay, it was in here somewhere then. Move K. Let me just add a note here. Okay, so one way or the other, that should get that number in W1. I don't know what move K does. We'll just take a quick look here. Move wide with keep. Moves now only shifted 16-bit value. Okay, I guess that's what that is. Alrighty, so this move X2. I don't know where it's getting that input buffer size thing. $34. Print num print and then that. Print num print and then that. Well, I don't know where it's getting that. I don't know why it complains now, not before. Okay, we need C-like. I guess that's it. Well, do I need to move? Um, well, it seems like they're using it. They work backwards. I think that's just the way that move K seems to help. So 741, the number should be 40487413. So I think this is okay. Yeah. Oh, okay. Good to know. Yeah. Right. So this effectively or shifts this, ors it into W1. But the problem is I have no way to know this was called. Oh, I guess the way is I break at start. Okay. All right, I'm gonna have to figure out this obj dump thing too. Man, obj dump. Minus S, maybe? Minus S, unit test playground. Okay, we probably want minus S and minus D, but I just want to find out where. I guess 104,000 is probably the start. All right, so we'll do a run. Yes. Okay, store that, store that, store that. We'll see what X2 is. Read X2. Yeah, 4,000. Okay, so this thing, mem read this. Oh, we don't call setattr, so there's no issue. All right, let's read minus C100. I'll get there. All right, so this is the space. If we're lucky, tcgetattr will fill all this stuff in. Okay, so are we stopped? Yeah, we are. Okay, we're just about to do the service call. Okay, so if we step and step, now we do a mem read. There's stuff. Woohoo! All right. Now, clearly, so our call did something, and it returned a bunch of stuff. So that's progress. Now, how we know what this stuff is, that's a little weird to me. We need to go back to the structs. Now, which of these things is going to be the one that seems the most like it? Okay. Yeah, we saw one like this before somewhere else, but okay, SGTDYB. And we really need the structure of term IO. Okay, well, I think we probably have it somewhere here. Well, kernel term. Okay, this may be it. TC flag T. that was one of those things we couldn't tell what it was. All right, but I think let's take a snapshot of this. Okay, we'll put this back up over here. Okay, so input mode flags. If this is, well, 1, 2, 3, 4, 5, 6, 7, 8. So in some theory of things, this could be the I flags. These could be the O flags, the C flags, and the L flags in the first two lines. Then we have basically a set of characters. Line discipline 4, and then I think this is our, let's see, so that's 7, 15, 16, 17, 18, 19, well, 15, plus 8 is 23, plus 2 is 25 bytes. I don't know if that gets us to 72, but well, this is 3 times 16, 4 times 16, 64, plus those 8 is 72. So I think, yeah, woohoo. I think we're closing in. This from here to here is 72 bytes worth of stuff, just like we said it was going to be 72 bytes. Now, I flag, input flags, we've got O2 to B. Well, let's see what that seems to be. O2. I'm not sure whether to go like hex or what. O2 is 1, 0. Then we got 0, 0, 1, 0. And then we got B is 8 plus 0 plus 1 plus 1, right? 1011, is that B? 1010 is A, so yeah, 1011. All right, so can we relate these C input flags to anything like that? Well, maybe the O flag is easier. It's O3, so that's 011 somewhere. Now, it's hard to know if they've flipped the bytes around or they've done the this or the that. Yeah, like is it big endian or little endian? I mean, it looks kind of backwards, right? I mean, these are all zeros in this flag, but it's a set of flags, so maybe not. But you would expect the flags to be in the low bits because it's sometimes 16, sometimes 32, sometimes 64. All right, but let's find that a definition of these flags. I don't think this is, well, no, this does look like it's possibly it. Okay, but the control flags, So I flag, O flag, this control flag is 4B. So that's a 100, and B we said was 1011. Okay, so 1 is tandem, 2 is C break. That sounds unlikely. 8 is echo. That seems like it should be on. And then 0, 0, odd P. I can't believe parity matters. Actually, I don't believe any of those really could make a difference. I mean, like NL delay, that's definitely old TDY stuff, because they had a printer carriage and it physically needed, half a second to get across the page back to the beginning of the line. And if you just assumed you could just shove NLs at it, from the far right and stuff, it would would be screwed up. Well, send out stop C out on queue full. Possibly half cooked doesn't sound right to me though. 1-1 tandem C break echo odd. I mean, who knows? But possibly. Okay, then the O flag is just 011. I don't know which ones are ins and outs. Oh, notice what they've done? They've made these flags 100% across. Huh. Two B02. Oh, I see what you're saying. Okay, so if it was 2B02, all right, if it was 2B02, that's still C break. And then, I don't know. Yeah. But you're right. It could be totally backwards. Well, B is 1011. 1248 is 4 bits. Yeah, I don't know how to read these. But that theory sounds kind of good, really. Like the lowest byte would be the first one. But you know what we could do? That's our get header. Okay. Well, here's the strategy anyway. We've got this that looks plausibly something. We could go to our C program, cast that structure to a void star, and print out the first 72 bytes of it as hexadecimal bytes or something like that. Or maybe even just print them as hexadecimal ints and see if they're set on the high bits or the low bits or what. Now, that... Yeah, I really wish people would just tell us what these kernel flags are, because I don't think we have to use them. That was the 0 time delay thing. Okay, but yeah, okay, let's try that. Let's go to our C program. Okay, and what can I do? Yeah, I want to look at this. All right. So if I made a struct byte 72, I forget how to define a struct even, my goodness. Okay, I'll look it up. Define struct in C. Actually, maybe union would be the better one. Struct this name. Okay. Yeah. So if I made struct byte 72, I just put the stuff in it. Well, I think I want to do this. Union byte 72 is char bytes of 72, or it's a struct term iOS term. Okay. Right. Now I can say bytes 72 pointer equals address of raw. Can I do that? Okay, byte 72, my bytes. Now my bytes dot term equals raw. Do I get my free copy? Must use union tag to refer to bytes. Like that? Expected semicolon after union, okay. Yeah. All right, so if I do that, then I can say, I equals 0, I less than 72, I plus plus, and I want to print percent x by bytes dot bytes sub I. And then I want to stop every 8 bytes and print. Okay, do I get something like that? And I'll say exit 1. That is true. Okay. Well, let's take a snapshot of this. Okay, we'll quit this. And we'll do a make. What are we making? This is our unit test demo. Playground. Make. No, he's not. Oh no, this is Kilo. So I want this to print a bunch of stuff and then stop. 26B 003 Now, how is that? 1, 2, 3, 4. Wait. 2, 4, 6, 8, 9. Well, I've done something wrong. Okay, well, we can still see the 2b up here. 3. Yeah, this could be, well, no, that's a little different. 4F, FF, FF. Oh, then we get 7F. 171512 FF. I mean, I think we're in the ballpark. FF 8025. I don't know why twice. Maybe I've been too clever with that print thing. Let's take this out. I mean, this would print, well, let's print 2x. Sorry, that would be smarter. What the heck? I don't even know. What? Is it dot 2x? I don't think that's needed. Now, how is that? Okay, but let's see our result here. I mean, I think they're in the ballpark of being the same. O2 6B instead of 2B. O3 4B. And then I think maybe I don't know. Why would this print out? I think because it's negative. Is there an 2UX? Is that the deal? No. Yeah, char sign. So we get these minus whatevers. Yeah, maybe we should convert them. That'll probably help a little. Except this is just weird. Oh, I don't have my 2 anymore. Oh, I do. Oh, percent O2X. Well, that was easy. Okay. O2 6B, O3 04B, CB 05, O4 FF, FF 7F 171512, FF 03 1C, 1A 19 19 13 16 OF, 01 14FF, bunch of zeros, 8025, 8025. Okay. I mean, we're seeing the same thing we're seeing in our assembly language program. So this is good. I mean, it's not the easiest thing in the world to get here, but I think this is promising. All right, now what those flags are currently and why they're what they are, we haven't decoded that. The only difference was 6B versus 2B. All right, and so that's a difference of 4. So this thing has a 4 set. Let's see, where can we find those? this one? 04 L case. Now that seems unlikely. 02 and then I guess that's the third digit, right? So 2. Isn't that weird? There is no 2 on that thing. Or 6. Yeah, why is this 3? It's a 1 and a 2. VT delay. Oh, there it is. Okay. Is it the right position? Oh, okay. Yeah, you're right. And that seems arbitrary to me. It hardly applies to a video terminal kind of context. But that's okay. So now all right, I think this is good. Let's make this into a little routine. Void print term struct takes a struct term iOS star pointer to struct, let's say. All right, let's take this, move it up. Take the exit out. Incomplete type union byte 72. Oh. Okay. Right. And then if I do print term struct address of raw. All right, and exit. I expect to get what we had before. And you know, I'm gonna change this to 15 just so we line up a little better with the others. Yeah. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Well, 0, 1, 2, 3, 4, 8, 9, 10, 11, 12, 13, 14, 15. Why didn't you work? Okay, let's undo that. Make sure we're consistent first, then I can play. All right, 026B, etc. That looks right. Okay, now instead of exiting, I want to do this thing again. And this one's before. Oops. Quit. Okay. Yeah. Still a 2000 that's not defined. I know, it's just so frustrating. But my point is kind of we don't have to care because we can see what the result of that he calls set adder on, right? So instead of 6B, it becomes 6/8. Well, that turns off 2 bits. 03 4B, this becomes 02. So it turns off 1 bit. 4300. Wait, 004B. Oh, excuse me. I don't know what's going on there, but several bits are being turned off. 4F, FF, 7F, 1715, 12FF. Those are the same. Oh, the third line from the bottom is different. 0100 14FF. 01. It's 01 instead of, or it's 0001 instead of 100100. Okay. CR2 TTY37. Okay. I don't think we have to worry about running into any Model 37 teletypes. The improvement on the Model 35, I'm sure. All right. Let's see. So my I guess what we can do, right? If we were to compare these things, maybe this is even testable at this point. We're getting to the end of the spike aspect. I can take the before. Well, I can say get adder. After your get adder, it should look like 0068, and then don't worry about it. 0200, or even we could put these in. I mean, it's 9 times 8 characters. It wouldn't be that hard to put this in as the expectation, with a little manipulation. We'd have to do that little trick bit we did before with the move K to get these all in one word. But we could certainly assert that our before and after on our thing to clear the bits for a term IO is correct. I mean, I think we're getting the call right. I mean, that feels close to me. I don't know if we want to assert the before, but we certainly can assert the after. I suppose we could do both because it's just sort of the way we want in our environment. I don't think I'm trying to be, I mean, I'm not trying to make this to run on anybody's system. I don't really, not a goal of mine. So having it easier to test for us and a little less portable is okay in my book for now. Okay, so if we create the after and send that to set adder, then I think we're good. Now, I don't know what TCSA flush. We're going to have to find out what that is. It's weird to me. Well, we didn't look for this one. But I'm skeptical that's it. I also don't know where this stuff is kept on my system, which is kind of unfortunate. Not in here. Yeah, I don't think this is the right file anyway. Yeah, that's more of a general system configuration-y kind of thing. What are you? Well, okay. TCSA flush. Well, the other one was this. Do we have termios.h? Flush. Well, that doesn't seem like the right thing, does it? TCSA flush is 2. Okay. Oh, well, that's very, very straightforward. Okay. Right. So this drains the outputs, flush the input. Okay. Then I guess that's what we have. We know this value is 2, so we can set up the service call to do the equivalent of this. File number is 0. This is 2. This is our pointer that we already know how to do. Okay. Now this constant, I don't even know if I need these. We'll go back to that article and maybe decide which ones are important. I think these two are the bomb. They're the ones we gotta have. This is maybe important because it says we want immediate character reads. Well, no, maybe we don't. We don't. I think we want to read when we're told to read. So maybe even that's not necessary. I think it's this L flag, which was the 4th word. All right, let's look at that one. Oops. 1, 2, 3, 4. This CB05, and what is it here? 1, 2, 3, 4. 4320. Well, now I'm not relating it so well. Just trying to get it in view at the same time. All right. 022B, that's the first word. 3, 004B, and then, CB05 becomes 4300, and the rest of the line is the same. So my guess is we just zap those 2 bytes and we're in business. Can I break the terminal? That would be the proof. Yeah. Well, we can in the C program. Let's make sure we can do that there first. tcgetattr. Okay. Let's take out this. Whoops, this. Okay. All right, so bang cc, bang, well, get it out. So, yeah, that should do this. Q, no, it doesn't. It did reset. Did it do this anywhere else? Huh. Well, even this doesn't break the terminal. I wonder if there's... I could believe the terminal driver builds in that protection and just restores it. But I don't know. Maybe it's too smart. Too smart for our program to destroy. I know in the past I've had applications like if you accidentally print a file full of control things or something, it can trigger some weird echo mode or turn off turn off normal processing and give you some weird stuff. Okay, but I don't think that's it. Okay. Right. We just have a few minutes. Let's see. Did we make an iOS doing anything? All right. I'm just going to start by checking in what we have. Whoop, what do we got here? Something's funny. Control C doesn't work, so something's blocked off. Okay, let's do this again. Yeah. Okay, well, we can certainly do it at the sea level. Alrighty. Let's commit this stuff. So, update spike to show contents of term iOS struct. All right. And then I think in terms of starting this, well, there's input. What is this testing? Stub. Reline. Well, this is more like the input for REPL. I think input is probably not the right place. This is more of a runtime thing. I'm almost inclined to put it here. Okay, so what's useful for 2-minute drill here? I think we want to let me capture the before and after on that thing. Output from kilo.c before and after. All right, let's make sure this thing is safe again. Okay, so cc kilo out. Okay. This is probably not the right place to put it. I should put it in the to-do. Okay, I think that'll be useful for us. And a note, well, this is sort of a finding. We need to change CB05 to 4300 and maybe more. Okay, but if we did that, that would be something. Okay, let's add IO tests. All right. And I'll pull some of this stuff. And that'll give us a start. We'll have to do the make file. I'll just give it a name for now. Before and after. Okay. Well, I think we've done a successful spike, that we've demonstrated the output from our assembly language level, that we got bytes that resemble this almost completely. A couple exceptions that we can't even quite figure out why. But in general, it does. Things match up to what we expect in terms of like C flag, I flag, L flag, all that stuff. And we've identified the place where we most need to change these flags to get into raw mode, or at least half-cooked mode. I believe what we'll do tomorrow is we'll make some function that turns these 2 bytes into these 2 bytes and plug in the tcgetattr stuff and see what we can do. Why the O1 moved, the one at line 38 versus 39. For 49. That's that vmin, vmm, whatever it was thing that controls how long do you wait for an input and whether you should just go automatically. But I think in our case, we'll just make it synchronous, and you whenever you call read, it will do a read, read byte or something. Okay. But yeah, we could go for completely identical, before and after. But I think the real thing is flip the flags that you care about. So I don't think that'll be too hard. Even some function that just says, set a byte in an indexed range or something, just give it, this is 0816 24, byte 24, set it to 43, kind of thing, would be enough. And then we'll put the calls in tcgetter, tcsetter. I think at that point, we will be able to make this read work and do that. So I'm very hopeful we'll finish that tomorrow, or at worst Thursday. And I think we'll take a little time. We had some things that were just cleanup kind of things. This one, I think in particular, I think we can improve the way our startup is. And we might throw in one of these debugging tools or something. But I want to be able to start next week on, I think Hangman's a cute little idea. So we'll probably do that. Load the flags, set the flags, string back. Yep. All right. Well, thanks for joining. I feel good about the progress here. It's a bit of digging around in both C and regular assembler, but we got there. So that's promising. Okay. And see you tomorrow or in the future, I hope. It's 2 to 4:30 Eastern time, 6 to 8:30 p.m. UTC, and have a good evening. Take care. Bye-bye.